All right, so today we are talking about lesson 2.3, converting between fractions and decimals. The main thing about conversion between fractions and decimals is that you kind of just do what the problem says to do. But let's go ahead and read through some of this important vocabulary. The first is terminating decimal and repeating decimal. The idea that you can divide any integer by a non-zero integer, you just use long division to write fractions and mixed numbers as decimals. These decimals are rational numbers and will either terminate or repeat. So terminating is a decimal that ends. So say terminate, ends, kind of like the Terminator. So repeating decimals are decimals that have a pattern that repeats. And notice there's a couple different things. Notice 1.333333 can be simplified as 1.3 and 1.151515. Notice the bar notation, not the fraction bar, my bad. The decimal bar is used to show which digits repeat. So if the 3 is repeating, there should be a line over the 3. Not 1.33 with a bunch of bars, right? So not that. So here you just figure out what's repeating, and that's what the bar goes over. Okay, so the idea is let's go ahead and write some numbers as decimals. Okay, so what we want to do is just use long division. Now, in order to do long division, we have to be able to convert our mixed number to an improper fraction. So the first thing we need to do is convert to improper. We do that by doing that multiplication method that we used to do, right? So 4 times 2 plus 1. So 4 times 2 is 8 plus 1 is 9. So when we think about this as negative 9/4. Now what does that say? That says 9 divided by 4. So we do 9 divided by 4. So 9 divided by 4. And of course our answer is going to be negative, so we just leave it alone. And so we say 4 goes into 9 2 times with a remainder of 1. Now what do we do next? Don't forget that decimal that's right here needs to come up. That's going to be a big mistake that people make. And then there's that placeholder 0 that's going to come down. 4 goes into 10 2 times with a remainder of 2. Once again, need a placeholder 0. And luckily, 4 goes into 20 an even number of times. 5. So our answer is negative 2.25. So 2 1/4, right? If you had said this fraction as 2 1/4, wouldn't that be a pretty easy decimal conversion? Would we have to actually do the long division for that one? Probably not, because 2 1/4, we know a quarter is 25 cents. Just kind of something to keep in mind. Now the next one I'm going to tell you right now is going to be a repeating decimal. And anything that ends in an 11 or that has a 9 on the bottom is going to be a repeating decimal. 11s, 9s, 3s, those are all definitely going to be repeating decimals. But let's go ahead and just see what decimal that is. So we need long division, right? Long division. We just set it up. 5 divided by 11. Well, we can't do 5 divided by 11, can we? No, 11 doesn't go into 5 evenly. But don't forget that decimal. Maybe do a placeholder 0. 11 goes into 50 4 times. So that'd be 44, 6. 11 goes into 60 5 times. And we get 55. And now we keep looking, and look what just happened. 11 goes into 50 4 times. And then a 6, oh, I bet you can tell what's going to happen. It's going to keep repeating. So once we see that repeating decimal, that repeating pattern, then we just have to write it as a repeating decimal. So 0.45, and that fraction bar needs to go over both the 4 and the 5. That's important. Okay? All right, so here are some sample problems that I want you to try. So I'm going to write it, and then I'm going to pause the video and ask you to try them. And you'll pause the video and you'll try it. So I'll write them down in black. So 1, I want you to try it, negative 6/5. Pause that video. All right, so to make this a little bit easier to do in my head, I actually can convert that decimal, that denominator, to a 10. So I can multiply this by 2 over 2, and this gives me 12 tenths. Well, 12 tenths. Well, how many tenths are there? Well, in decimals, this place value is the tenths, so there are 12 of them. 12 tenths. And of course, it's negative. All right, here's your next one. Go ahead and pause this video. Negative 7 and 7/8. Not 7/8, sorry. Scratch that. Negative 7 and 3/8. Go ahead and pause the video and do this one. All right, so I'm going to need to do long division for this one. So why do I not need to worry about this 7? Since I'm writing it as a mixed number, I know the whole portion is going to be 7. I only care about the decimal part. So 8, or 3 divided by 8. Well, 8 goes into 30 3 times. That's 24. I'll bring down that 0. 8 goes into 60 7 times. That'd be 56. 4. Now 0. 8 goes into 40. A nice even number of times. So we didn't need to worry about this portion. We didn't, like, that one was already set for us. No biggie, right? And so then we just needed to get the decimal portion. And of course, it's going to be negative. All right, try another one. We're going to do 4 of them. I'll zoom in on this next one. 3. It's going to be negative 3/11. I'm telling you right now, this one's going to be a repeating decimal. It ends in 11. We know that because I'm telling you it does. Okay, it's going to be a repeating decimal. Go ahead and pause that video and try it. All right, so 11 goes into 3, well, 0 times, but it goes into 32 times. That's 22. Goes into 8 7 times. That's 77. And notice the pattern is going to repeat again. So it's going to be negative 0.27 repeating. All right, let's get our last one here, number 4. Sorry, I got to zoom in a little bit more here to get it to squeeze that problem into the page. All right, so number 4 is going to be here. It's going to be 1 and 5/27. Now, this is going to be a repeating decimal because 5 and 27. I'm going to go ahead and just pause the video. All right, so here's our work for that one. You're just going to have to trust me on this one because I ran out of room on my paper to write it down. So 1851 is actually the answer to that. And it's repeating. Okay, so let's move on. All right, so moving on to the next portion. Now here's the deal. Any terminating decimal can be written as a fraction whose denominator is a power of 10. This is kind of a shortcut way of getting those decimals to fractions. So to convert decimals to fractions, you just need to get the denominator as a factor or as a multiple of 10. So 100, 1,000, tenths, etc. So 0.48, we would actually just say that as 48 tenths or 48 hundredths, right? 48 hundredths, which is exactly what that is. And then you would simplify, of course, simplify. And then another way to do that is just to look at it as a product of factors. So writing this one as a terminating decimal as a fraction, well, weird. So we would say this as negative, not negative 0.26, but negative, how would we say that? Well, we would say this as negative, negative 26 hundredths. So we would write it as negative 26/100, right? Negative 26/100. And we look for common factors. I can tell that this has a common factor of 2. So if I divide both those by 2, I get 13/50. And then I have to just check, okay, 13 is a prime number and 50, it's, all right, so those do not go into each other. So our final answer is negative 13/50. All right, so here are some samples for you to do. All right, number 1, negative here. All right, pause the video and try this one. All right, so we would call this 3 tenths, right? So 3/10 with a negative sign, right? Okay, next one. All right, pause the video and try that one. So this would be 125 thousandths. So 125 over 1,000. Now, there's going to be common factors of 5 all over the place. So I would actually do a common factor of 25. So I would say, how many times does 25 go into 125? That would be 5 times. How many times does 25 go into 100? That would be 4. Okay. How many times does 25 go into 1,000? All right, well, that's a little bit different, right? It's going to be a little bit different. 25 goes into 1,000. 40 times. Well, we know 5 over 40, that can still simplify, can't it? 5 over 40 can still simplify. We can common factors of 5, right? So 1 and 8. So this answer is 1/8. All right, I'm not going to show the work for the next couple, but I bet you can do them both. Go ahead and pause the video and try these too. So as you see, negative 3, or excuse me, not negative, negative. Negative 3 and 1/10, and negative 10 and 25 hundredths, which is a quarter. That's one you're going to want to memorize, okay? A quarter and 0.25, you're definitely going to want to memorize that one. All right, so we've got one last problem. This is a little bit tricky, but it's really just a bunch of simplifying. So the table shows the elevations of 4 sea creatures relative to sea level. Which sea creatures are deeper than the whale? All right, so what we're looking at is which ones are more negative than the whale. Okay, so we can automatically tell that the squid is more negative than the whale, right? Because -2 is definitely deeper than -0.8. We can also tell that the anglerfish is deeper because an improper fraction and a regular decimal. But what we want to do is just convert all of those fractions to decimals. All right, so -13 over 10, that becomes -1.3. -2/11, we'll do some long division for that one in a moment. And -2 1/5 is -2 2 2/10, right? Or -2.2. Now 2 divided by 11, 2 over 11. 11 goes into 2 0 times. 11 goes into 20 1 time. 11 goes into 90 8 times. My computer's really running hot right now, so sorry, the sound in the background probably is frustrating. That's 88. And then we're back to that process again. You can see that it's going to repeat again. All right, so that's going to be, because it's an 11. 11 when the denominator is always going to be repeating. We get -0.18 repeating. So which ones are less than that one? So let's summarize our findings by saying anglerfish and squid are more negative. So they are deeper than the whale. All right.